Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Bakersfield West Rotary STROOPE Family Foundation, Panama-BUENA VISTA Union School District, Bakersfield City School District, Kern High School District, and AC Electric Company, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
I'm Marylou.
And in studio with us we have Hudson. We'll meet Hudson in just a moment. But Marylou, there are a lot of ways to get a hold of us. What are those ways?
There are. If you need help with math today, we have math tutors here until 5:30. You can call us from Bakersfield at 636-4357, or you could call us toll free at 1-866-636-6284, or you can email us, dothemath@kern.org, or we're on social media. You can get us anywhere, Facebook, Instagram, Twitter, or YouTube.
All right, thank you very much for that. Well, as I said, Hudson is in studio with us right now. And Hudson, where do you go to school and what grade are you in?
Stockdale, and I'm in 5th.
So you're in 5th grade?
Yeah.
How's 5th grade going so far?
Interesting.
It's interesting. Ah, that's a very good answer, because a lot of kids go, oh, it's going pretty good, it's pretty well, I don't like it, it's bad. What is the most interesting thing about school this year?
I don't know. It's online, I guess.
Okay, so it's online. Do you like doing stuff online?
Not really.
Not really. So you would rather be in the classroom, right? And I think most kids would agree with that. A lot of kids like that they can do online things, because there's some students that they just like working by themselves and they are more productive sometimes like that. But I think most of the kids would like to be back at school and doing things in the classroom and stuff like that. Because I know, like in 5th grade, once you're in 5th grade, you can do a lot more things too, right? Like they have sports you can do, band and chorus and stuff like that. Have you thought about any of that stuff that you might want to do?
No.
You've got time to think about that later on. All right, well, we're going to have you working on some math problems, but first, let's take a look at today's Math in the News. All right, so today's Math in the News, I found an article and it said, options terms are Greek to you. So this came out of the Wall Street Journal, and you can kind of see the graphic right there. And there's a lot of information on there. So I kind of took the key points and we'll discuss them today. First, Hudson, I have a very important question for you. Do you know your alphabet?
Yeah.
Can you start off by saying the alphabet?
A, B, C, D.
All right, so you got the idea, right?
Yeah.
Do you know the Greek alphabet?
Not really.
Most people don't, right? But that's why I just want to check, because you might just rattle that thing right off there and you never can tell. So let's take a look at the Greek alphabet and symbols. So it starts with alpha, beta, gamma, delta, epsilon, zeta, and it goes on and on and on. You can see those things down there. So quickly, Marylou, by looking at the Greek alphabet and symbols, anything recognizable to you or bring back memories or something that you can relate to?
Well, I'm just thinking of the names and thinking of college, like reference to college, you know.
Right, fraternities and sororities.
Fraternities and all that.
Okay, yeah, so that's where a lot of people will see those. You'll actually see the symbols on the fronts of the houses where they're at. They have clubs and things like that, and those are the symbols that they use. And there are ones that they use specifically in mathematics. And there are ones specific to the stock market. So before we go on, let me ask you another question. Do you own any stocks?
Not that I know of.
Not that you know of. All right. Well, when I was your age, I didn't either until very recently. I didn't know, right? But you never know. I mean, you could have said, well, as a matter of fact, my portfolio is quite full with all of these different things. And I'd be like, whoa, you're off to a nice little start there. But anyway, let's go ahead and take a look at some of the symbols and what they mean as far as mathematics and specifically the stock market. So delta is a ratio that measures how much an options price is expected to change for every $1 shift in the price of the underlying security. Now, some people go, well, that's nice. What does that mean? Okay. Well, when you become involved with the stock market a lot, and there are people that just trade stocks all the time. Have you ever like traded cards, like baseball cards or Pokemon cards or anything like that?
Not that.
But you've heard of these things, right?
Yeah.
Okay. So people trade these things back and forth, right? And they go, well, you know, I'll give you 2 of this for 3 of those, right? And that's what people, they get paid to do this type of thing, all right? Just at a higher level with more money involved. So let's take a look at the next one. Gamma measures the rate of change in the delta of an option for every 1 point move in the price of the underlying security. So once again, I know these are a little bit more advanced than what most kids are going to be working with, but you would be amazed how many middle school and high school students are doing things with stock market and will know what these terms are. Theta measures the rate of change in an option's value due to time and is usually expressed as a negative. All right? You know there's positive and negative numbers, right? All right, so you're on this. We've got one more. Rho measures the expected change in an option's price for every 1 percentage point change in interest rates. Now, that may not all make a lot of sense to you guys, but if we take a look at this one might. So, have you ever heard of Netflix?
Yeah.
You have. Have you ever seen Netflix or watched anything on it?
Not very often, but yeah.
But you have, right? Marylou, heard of Netflix?
Yes. Oh, yes.
John, our director in studio, heard of Netflix? Indeed he has. All right. I obviously have heard of Netflix. It would be few and far between the people that we find in our community that have not heard of Netflix. So let's take a look at Netflix right here. And we can see since 2017 what has happened to the price. So Hudson, this is 2017, 3 years ago. It started down pretty low. It was under $160. Does that make sense to you? All right. Since 2017, has Netflix gone up or down?
It's going up, I think.
Right, it's gone up, right? See how it's gone up, 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 up. And then what happened?
It went down a bit.
It went down a bit, right? But then it went back up again.
And back down.
It went back down again, right? Can you think of any reason why Netflix might go down? Like why it wouldn't be worth as much? Can you think of anything offhand?
No.
I know I'm throwing you on the spot right there, but Marylou, any ideas why a stock might go down?
Maybe their prices increased, or they had a change to their lineup.
Right,
where
many
people
factors.
decided, I'm not going to continue with it.
Right, so their price may have increased and some people may have said, well, I'm not going to be able to do that anymore. The lineup may have been altered and people just didn't feel as though it was worth as much anymore. There may have been new competition taking away from some of their market share. But anyway, we can see that it's gone back up, right, during the last year. Now here, take a look at this, Hudson. This is kind of the beginning of 2020, all right? It was doing pretty well and then it went way down. Can you think of a world event that may have made that go way down? Wouldn't you? You know what it is, don't you? Right?
Yeah.
Why are you wearing that mask right now?
Because of Corona.
Right, because of the coronavirus, right, and COVID, right? So the same thing here. All the stocks, just about every single stock in the world was high. And when COVID hit, they all went down because people were not sure what was going on. And then you can see Netflix is going back up now, isn't it? Right? And one of the reasons why is because people had to stay home more often, right? If you're going to stay home, what do you think you're going to do more of?
watch movies.
Yeah,
I
you can be
guess.
watching movies and things like that. So that is why Netflix is going back up here. But I have one final question for you. Overall, from 2017 to now, has Netflix overall gone up or gone down?
It's definitely gone up.
It's definitely gone up, right? It's gone up almost double, right? Because 160 and 160 would be 320, right? So it's gone up almost double. So just a little brief history on the Greek alphabet, what it has to do with the stock market, and taking a quick look at one of the stocks right there. That is today's Math in the News. 636-4357 is that phone number. We do have phone tutors available until 5:30 most Tuesdays and Wednesdays throughout the regular school year. Hudson is a 5th grade student from Stockdale Elementary, and we're going to get started on some division in just a little bit. So are you ready for that?
Yeah.
All right. But first, we're going to go out and see what's going on with Affinity Trucks and how they apply math and science in the real world.
We're here today at Affinity Truck Center, up a little north on the 99 here in Bakersfield. We're going to talk a little bit about the business of truck repair sales, as well as some of the engineering behind some of the mathematical decisions that go into the day-to-day operations here at Affinity. So today we're going to talk with Roy Peters, our general manager, as well as Brandon Snyder, who works with part sales. Gentlemen, thank you for joining us today.
Oh, we're glad to have you here.
Likewise.
You know, when students start the year in math, one of the first skills they start to play around with, generally in like 4th, 5th, or 6th grade, is also one of the skills that students kind of brush off because it doesn't deal with precise numbers, and that's estimation, rounding to the nearest 10, 100, or even decimals. And right up front, it doesn't seem like a super helpful skill to students. You got to confuse them. You got to kind of bring them there. But gentlemen, you use estimation every day in your business.
Yes, we do.
Yeah, yes, we do. We do a lot of estimation in our business on a daily basis. I mean, the truth is our business is primarily numbers. You know, we spend a lot of time talking and looking at numbers and percentages and fractions, and you know, we do numbers. That's what we do here.
Having a number sense is really helpful, but the types of numbers that you work with are pretty significant when we think about it. So, you know, how does estimating help as far as some of the decisions that you make as far as parts or giving quotes to customers?
So let's just start something off with basic simple. Let's say that you bring your truck in. We're going to say that your truck is Math Trucking Incorporated. You're going to bring your unit in, you're going to get it checked out, and obviously it's going to be diag because you have a problem. We're going to start with something basic and simple that we do here in the shop all the time, which is a basic transmission rebuild job. Once the technician is diagnosed that the transmission needs to be rebuilt and we've been given the approval to go ahead and build that estimate for the customer, basically what we'll do is we'll go through what exactly is going to be done to rebuild that transmission. Any parts, kits, any type of labor is also going to be included in that. Once we've built up all the parts and given the estimation, now we need to figure out exactly how long is it going to take that technician to actually rebuild that transmission. So Volvo and Mack, what we work for, they have specific amount of hours for each technician. How long it's going to take to actually remove that transmission, how long to inspect that transmission, and then to rebuild the transmission and then reinstall that transmission. So for instance, to remove the transmission, Volvo and Mack has given us basically the technician to give 1.4 hours. So basically, if it takes 1.4 hours to remove that transmission, and per hour that we build for that technician for a labor is going to be, let's just say for instance, it's $100. Well, 1.4 times $100, you're basically going to get $140 is what it's going to cost just to remove that transmission.
So you're estimating not just dollar amounts, but you're estimating all kinds of quantities like time or weight, or even just the estimated labor that would go into a project and the amount of parts that would go into that. So estimating helps as far as getting a bigger kind of general idea of what everything is going to conclude with as far as the cost and as well as time.
Yes, it's very important because obviously as you, the customer, you want to have a really good idea of exactly how much you're going to spend. Is this going to be worth you actually investing your money and actually getting this job complete so that you can get your truck back on the road and start making yourself more money? So when we make that phone call to the customer, we want to make sure that we have the best estimate possible for them so that they can make that decision on whether they're going to give us the yes or the no answer.
And that's a big decision for a lot of truck drivers because a lot of the work they do is essentially their own business. They've got to figure out if this repair is going to cost them a certain amount of time off the road, which is time they could be making money. It also might have to do with the long-term investment of a truck that they may need to buy in the future. Is it worth this much money to continue to repair this vehicle, or do I need to start thinking about investing in a new one?
Exactly. And a lot of that comes into with warranty. Warranty is very important. Just for that reason is because, if you've got a truck that's got somewhere between 100 and 500,000 miles, and you know that you're going to get at least another 500,000 miles out of that truck, it's a no-brainer for you to say, hey, you know what? If I just go ahead and rebuild this transmission, and I've got warranty for at least another 2-3 years on that transmission rebuild, and I'm going to get at least another 300,000 to 500,000 miles on it, then once you give them that estimation, then they're going to be able to go back and do the estimation on their own books and say, hey, is this job worth it? Do I need to go ahead and move forward? Or no, I'm going to go ahead and pass. And then, like I said, I might be able to talk to Roy here and our sales team and say, hey, what kind of truck do you got for me?
Well, a big part of that is looking at the science behind the repairs. Brandon, thank you very much. When we come back for our next segment, we're going to talk a little bit about how forces come into play and calculating just the right amount when we look at torque. But for now, we're going to send it right back to the studio. Mike, take it away.
All right, thanks for that, Devin, and also thanks to Brandon and Roy out at Affinity Truck Center right there. We do have phone tutors available until 5:30. More importantly, though, we have Hudson in studio with us. Why was I thinking Hunter?
I don't know.
Crazy old man, huh? All right, Hudson is in studio with us. I don't know why they ate you or something. All right, anyway. You've been working on division in class, correct?
Yeah.
All right. Over to the board, young man. It's time for you to start doing some work. So, either you or Mary Lou can write this on the board. I want you to put 24 divided by 8.
Okay, Hudson, you want to write that on the board for us?
Right,
24 divided by 8.
24.
And Hudson, can you do that in your head, or do you need to work it out?
I can do that in my head.
Go ahead and write the answer then, if you know what it is already. All right. So you can do that pretty easily, right? Okay, erase the 3 for me.
Oh.
And after the 4, I want you to put an 8. Now, go ahead, can you do that in your head, or do you need to work that out?
No, I probably can't.
You probably need to work that out?
Yeah.
All right, so you and Mary Lou are going to start on that one right now.
So, Hudson, what's the one thing that you do know, looking at that problem? What do you do know?
That 8 doesn't go into 2.
Right, 8 doesn't go into 2. So can you put like an X or a 0 or something over that?
Above the 2.
Over above
yeah,
the 2?
So just do it like that.
Right here.
What?
Here, let me help you out.
Wait, no. Wait. Oh.
How about right there?
Okay.
Okay?
Okay.
Now, what else do you know though?
That 8 does go into 24.
Okay, how many times does 8 go into 24?
3 times.
Okay, put a 3 there.
3 here.
Yep. And what is 3 times 8?
3 times 8 is 24.
Why don't you write 24 below 24? So let's subtract that. What's 24 subtracted by 24? Perfect. Now do me a favor and draw a line underneath that 8, that one right there, and then put 8, write 8 underneath the arrow for me.
So it's 8.
So now let's think, how many times does 8 go into 8?
Once.
Perfect. Let's put a 1 above.
Like
and
one-
again, let's multiply. What's 1 times 8?
1 times 8 is 8.
And put that underneath there for me.
Mm-hmm.
Yep. And let's subtract.
So 8.
Are we done? Is there anything left?
No.
So what's our quotient then? What's
31.
Is what?
31.
There you go.
Now,
That's
what
it.
I'd like you guys to do is before you erase it, check it.
Okay. So we have to check it. What is the opposite of dividing?
Also dividing is multiplying.
Multiplying. So we need to check that
31.
248 divided by 8 is 31. So
So-
what are you gonna multiply?
31 times 8
Perfect, okay, do that for me.
would be
And walk
Yeah,
me
you can
through
rewrite it if
Yeah.
you like.
So tell me what you're doing. What are you gonna do first?
multiply the 1,
Perfect. And what does that
That's
equal?
the 8, right?
Yep, you got it. And what do you do next?
8 times 3
Is?
24. So it'd be 24, so you have to carry the 2 over
But do we have our answer already, Hudson? Did we end up with 248?
yeah.
We did. So we know that we are right by checking our work by doing the opposite. So we know that 248 divided by 8 equals 31.
And we checked. So
We checked it. So put a big check mark next to that 248 for me. Perfect. All right.
Nicely done. All right,
Next
Hudson,
one.
erase the board. Ah, you caught on to that little trick pretty quickly there, huh? All right. So Hudson, in the middle of the board, draw your division symbol again. Some call it the division house. Go up a little bit so you have some room to work with. Yeah, erase that one. Go up a little higher because you'll be doing a lot of work below it.
oh gosh, small.
That's all right. Bring the other line down more, that's all.
There you go.
There you
Perfect.
go. Okay. Hudson, you get to choose the number on the outside. 4. All right, I get to choose the numbers on the inside. Let's go 2, 0, 4, 8. All right, go to it. You've got
Okay.
Marylou to help you.
So let's think of what we just did, Hudson. Okay?
Yeah.
So where would you like to start?
4 does not go into 2.
Okay.
So 4 does go into 20.
Okay.
5
let's
times.
start there.
So 5 here.
I love the place where you put that. Perfect. So what's the next step?
And then when you bring the 5. Wait.
I'm
no.
going to do a little thing right here to help you.
Yeah.
I'm going to do a multiplication sign.
Yeah.
So what you're really doing is you're saying 4 times
6 or
5.
5.
What does that equal again?
20.
And where are you going to put that 20?
Right here, right?
Perfect. Oh, not right there. Put it exactly underneath the 20.
Oh yeah. Okay. And then wait, I got it.
There you
20.
go.
And then subtract that, and you get 0.
Okay, and then what
Then
did we?
Bring this down, get
Lovely.
4. And then do 4 goes into 4 one time. So put a 1 here, and then 4 times 1 is 4. You you go to
Where are you going to
Put
put
the-
that 4?
4 right here.
Okay.
You subtract that, and then you get
Let me put it
where?
there for you.
Put 0. You get 0. You bring the 8 down. And it's 8. So then 8 that goes into 4. 4 goes into 8 2 times.
Okay. Where are you going to put the 2?
Or-
Oh,
no, not
wait,
that.
wait. Where are we going to put that 2 at?
I'm gonna put the 2 up here, right? 2 right there.
Great.
And 2 times 4 is 8. And then minus, oh gosh, is minus 8 minus 8 is 0.
And now that we hit 0, right, at the end, what do we have to do to make sure we're correct?
Now, I know that he knows how to check it,
Okay.
so that's good. So what is the final answer?
512.
There you go. Nicely done.
Good
Because
job, Hudson.
I've got another great problem for you to work on, so I don't want to waste your time
Okay.
checking that problem right there. All right, young man, erase that board. Put up your division sign again. Put up the... All right, hotshot. Pick the number on the outside. 6. Excellent. Let's go 1, 2, 7, 2. All right. Be a little
Okay.
different for you now.
So start it off for us. Okay.
So 6 doesn't go into 1. but 6 does go into 2.
There you go.
2 times.
Okay.
And then 6 times 2 is 12. And then when I minus, subtract that, you get 0, bring the 7 down. And then 7, wait.
You're right.
7.
Well, 6 goes into 7.
6 goes into 7 1 time. And then 1 times 6 is 6.
Correct.
And then minus that, get 1.
You're on a roll.
And then you want to bring the 2 down, make that 12. And then 6 goes into 12 2 times.
Oh, where's that 2 go?
No, not right here. It goes 2 times. And then 12, and then 2 times 6 is 12. And then 12 minus 12 is 0.
I think Mr. Christian tried to trick you, and I don't think he got you.
That's all right. We've got plenty of show left to go here. So nicely done, Hudson.
Great
You've
job,
done
Hudson.
some great work right there. And because of that great work, you've got yourself a meal courtesy of our friends at Chick-fil-A. So congratulations on that.
Good job.
There you go. Do you like that stuff? You ever been to Chick-fil-A?
No.
No? Oh,
Once.
you're going for a treat when you go to
Once.
Chick-fil-A, young man. Let me tell you, the old man, ooh, I love that Chick-fil-A. Not much I don't like anyway. All right, you know what? We do have another opportunity. We're going to go visit with Devin out at Affinity Truck Center once again and see what they're doing out at
Hey,
Affinity.
thanks a lot. Welcome back to Affinity Truck Center. I'm talking right now with Tony Martinez, diesel technician and trainer here at Affinity. Tony, thanks for joining us today.
No problem.
I want to talk about a really significant term in the work you do that may not get a lot of discussion in middle school or beyond science, but it matters because of the work that you do, and it's called torque. Now, torque is a term that students may hear, but they may not necessarily be clear on what it means. So describe to our audience what torque is.
So on an engine, when we're talking about assembling it together, torque is super important. For the fact that we want the engine to go back together and stay together. So
when you talk about torque in relation to some of the bolts that you work with and fastening and securing bolts to some of the hardware here, you're talking about how strong these get tightened. So it's about force and rotation?
correct. So basically, what torque is just the amount of force you're applying to on our instance a bolt.
Now, generally when a lot of our audience works with things like bolts, they're using hand wrenches or maybe a ratchet, but they're still kind of twisting it by hand.
Right.
Now, if you're looking to be very precise with torque, that's really tough to do by estimating, judging by your own strength.
Correct. So we have a torque wrench. A lot of the bolts on the outside you'll see, it'll have a basic one-step torque. A lot of these are 10 mil bolts. They're going to be torqued down to 18 foot-pounds. On the inside of the truck, it's a little different. We try to get a little bit more precise out of the torque. So what we do is we'll do a torque and turn, which is basically a torque spec, which is like 44 foot-pounds and an additional 30 degrees.
So torque is measured in the unit of foot-pounds, which is
Correct.
interesting to a lot of our students when they hear that, because they think about measurements either as length or as weight, but foot-pounds sounds like we're kind of bringing those two together. So how do foot-pounds relate to torque?
Sure. So there's different units. Like here, of course, in the United States, we do a lot of foot-pounds, but a lot of trucks that are from other countries, they'll use other units. So I can switch this up to, like I said, this is the angle. Give it a second, I calibrate. I might have to put it down.
Okay.
Quick.
So part of the measurement is the angle at which the wrench is, in which the tool is held.
Right. So once you start, the angle starts going. But like I was saying, there's different units. So there's, units right here. There's inch pounds, there's Newton meters, and then I think it's centimeters. I'm not sure what that one was. And then what we use is foot-pounds.
So it's very precise as far as how much ground is covered with exactly how much force applied.
Correct.
So guide us through like how we might use this in one of our.
So like I was saying, every bolt has a torque spec, and all you're trying to achieve is a perfect stretch on a bolt. If you under tighten a bolt, it's going to come loose. If you over tighten it, you're going to have two things. You're going to break the bolt, or you're going to stretch the bolt. So because it's too tight, or it's stretched so far out that it's gonna actually loosen over time and come loose anyways.
So you can't just, muscle it up as hard as you can to get it in there. I think a lot of people have that misconception.
Correct.
You have to be very precise with the amount of force applied during the rotation as you secure the bolts in place.
Correct. Would you like to give you a little demonstration?
Yeah, go for it.
So like I said, these are 8 mil bolts. They usually go get torqued to 18 foot-pounds. If I was to go all the way through and make sure these are all tight, I know that one's tight, I know that one's tight, and I know that one's tight.
So it measures the tightness without you having to go extra farther.
Correct.
So that's really helpful. It saves you a lot of energy.
Especially with the turn to angles, I don't have to stop, get my old school metal angle finder. This torque wrench pretty much does everything for us.
So there's a lot of mathematical components that are entailed here. You're not just talking about geometry with angles that are applied, but you're talking about rates with the relationship between feet and pounds to calculate torque as a unit. And then you're also talking about the different units you're using. You can convert that to, inch pounds, where we know that there's 12 inches in 1 foot. But also there was a metric version of torque where you had to convert kilograms and centimeters as well. So there's a lot of different relationships that come into play with something as simple as what would appear as tightening a bolt. But because torque is so significant, measurements need to be precise.
Yeah. Especially with these engines, they get used extremely hard every day. The only time they shut down is when they come in. So when they go back on the road, it's our job to make sure they stay on the road.
Well, Tony, thank you very much for walking us through that concept. It's torque, it matters, and it's about applying just the right amount of force. So when we come back here to Affinity Truck Center, we're going to talk a little bit more about the everyday work that goes on here and math is applied with gears and transmission. How does that factor in? We'll find out in just a moment. Until then, we'll send it back to the studio. Mike, take it away.
All right, thanks for that, Devin. And it is torque, it does matter, and it is force. So we will learn a little bit more about all of that when we go back and visit with Devin once again. We do have phone tutors available until 5:30 this afternoon. You can also email us at dothemath@kern.org. Sometimes there are students and they can't call us on Tuesdays or Wednesdays during these hours, so you can email us. If you email us, it would be best if you emailed us on a Monday. That way we'll be able to get to it on a Tuesday or Wednesday. If you email us on a Thursday, we can probably get to it, but it sometimes may not get answered in as quickly as you need the answer sometimes. So we do have email available for you as well. In studio, we have Hudson, a 5th grade student from Stockdale Elementary. And I forgot to even ask you, how long have you been at Stockdale? Your whole life, or how long?
Pretty much since kindergarten, I
So
guess.
since kindergarten, so you're pretty comfortable with it.
Yeah.
If there's one thing that you could change about school, so just pretend that you're at school, right, like normal. If you could change one thing about school, what would you change?
I don't know.
Like, is there anything like the time of school, out on the recess playground? Is there any, like, it could be anything.
No, not really.
Do you like the hours that school are? Like, you basically
Yeah.
start at 8 o'clock and you go until about 3 o'clock?
Mhm.
So those hours are good?
Yeah.
You
I
don't,
like 'em.
you don't want to sleep in and maybe start school at 10 o'clock?
No.
You don't want to go early or start at like 5 in the morning?
No.
That'd be a little early for the old man too. Anyway, all right. Well, good. I'm glad that school is everything's going well with it right now. So, you ready to do some more work?
Yeah, I guess.
All right. Have you ever gone shopping?
Yeah.
No. What kinds of things do you go to the store for?
Food, usually.
Okay. Well, you know what? We're going to take a look at Post-it notes. You know what those things are, right?
Yeah.
Okay. So we have 3 different options, and you need to figure out the best option for, like, the best bet for you, the most bang for your buck, let's say. All right, where you get the best value. Okay. Because if I said you could buy this pencil for $1, or I will give you these 3 pencils for $2. So you can get 1 for 1, or you can get 3 for only 2. Which one would be the better buy?
The 3.
The 3, right? Because you're paying less per pencil.
Yeah.
That's what you're going to be doing right now. Okay? So let's take a look at the problem together. So we have a 12-pack of Post-it notes for $9.99. So if you guys want to do that one first,
Okay.
and then we'll go on to the other ones.
Can you write that for us, Hudson, on the board? Just put 12 equals $9.99.
Wait.
Perfect, yep. Okay. And then the next would be 18
Wait, then do 18.
equals $29.99. And the last one is 24 equals,
Or
is it 37?
37.11.
Oh,
Yeah, I just erased it. There you go.
Okay, so Hudson, what we're going to do is figure out the unit price, and unit means per one. How much one is going to cost? So if we figure out unit price, then we can find out which is the best value. Do we want something that is higher in price or going to be lower in price for the unit rate?
depends on how many you want.
Well, if we figure out how much one is, okay, are we going to want the lowest price when we find out the one?
Mm.
Yeah, we're doing post-it
Yeah.
notes, right? Okay, so we know money, right? We know that money pretty much goes to the hundredths place value, correct?
Mhm.
So that's where we're going to want to kind of round to, is the hundredths place value. So we're going to do some dividing, all right? So the first thing is, let's do the 12 equals $9.99. So obviously in the house is our $9.99, on the outside is 12, okay? So go ahead and write that division problem for me.
Wait, so,
Yeah, write it up a little bit higher. There you go. So 12's on the
12.
outside, and in the house is $9.99. And have you dealt with decimals yet?
a little bit.
Okay, well, we know that that decimal point right there, let's bring it straight up above the house. Perfect. Okay, now let's use our same division rules that you did last time. So what are you going to think first? Oh, no, that was perfect.
I don't know.
What are you thinking first? Let's, even in your mind,
Well, 12 doesn't go into 9.
no, it doesn't.
No.
But does 12 go into 99?
Yes.
So we're going to kind of ignore that decimal point in the house, okay? How many times do you think 12 goes into 99?
1.
Let's think of, well, we know that 12 times 9 is going to be greater, right, than 100. What's 12 times 8?
Wait, 96, right?
Uh-huh, yeah. So is that pretty close?
Yes.
Okay, so let's throw an 8 above the 9.
Minus 9.
Oh, not that one,
No, this
99, that one. There you go.
8.
And then what did you say 8 times 12 is again? 90.
96.
Perfect. Put that 96 underneath and then 99. Oh,
Wait,
over.
no.
There you go.
You do that in your head, 8 times 12?
You did.
Sweet. All right,
Yeah.
keep going.
Okay, so what are we going to do with the 99 and the 96 now? Just like we did before.
We're gonna subtract
Right.
99 from 96.
Minus 96. What do you think? 99 minus 96, what is that?
3.
Oh, good job.
Wait,
And then
no,
what are we
wait.
going to bring down?
Bring down the 9.
Okay. So again, 12 times what number is close to 39?
12 times what number is close to 3?
3, perfect. What's 12 times 3?
12 times 3 is 36.
Okay. Go ahead and put your 3
Wait, so 3
and put your 36.
and 36. And this, that's 9, so it'd be 3.
Okay, so we're not done yet, are we?
No.
So what we need to do is, when there's nothing there, there's always a number we're going to use. And that number would be
0.
0. So we're going to bring that 0 down. We want to stop in the hundredths place value, but we need to go one more because we need to know what to round this 3 to. So 12 goes into 30 about how many times?
30, it goes to
Well, we
2.
know 2, right? And what's 12 times 2?
24.
24. Okay, we're going to stop right there because this 2 is really important. Am I going to leave this at 83 cents or am I going to round it up to 84 cents? Remember, we're going to look at we're looking at the 2. Remember your numbers when we're rounding?
Wait, no.
If there's 0 to
You
4,
round it down.
we keep it, right? We go down. But if it's 5 to 9, we go
Up.
We go up. So we're going to leave that little clue for us. So are we going to keep this at 83 cents?
Yes.
Okay, put over here equals 83 cents for me. And let's put that decimal right there, okay? So we know that that's a decimal. Okay, now you're going to do the same thing with the next one.
So you can just erase that work you did on the
Yep.
side. There you go.
And let's go ahead with the 18.
Wait, so let's do 18, and then do 29, 89, nope.
Okay, so again, we know that bring your decimal point straight up first, so we know where it goes. Okay, 18 goes into 29. How many times do you think?
Once, right? Wait,
Perfect,
yeah,
yes.
once.
So put that 1 above the 9 and bring your 18 down and subtract.
The 18 down.
Yep, underneath your 29.
Yep.
Perfect.
And then do this. And
What's 9 minus 8?
wait, so then, so harder. So 11?
Yeah, perfect. You're doing a really good job with mental math there. So let's bring down the 9, the other 9.
That's 9. Right?
So yes. So now that's a pretty big number, right?
Yeah.
So we kind of need to estimate, all right? Let's think about this. How many times, let's go over here and kind of play with it. How many times, just throw a number out. How many times do you think 18 goes into 119? Just throw a number out.
11.
Well, between 1 and 9.
9.
9? Okay. So I'm going to do some calculation for you real quick. We know that that's 72, right?
Mm-hmm.
And then 9 plus 7 is
16.
that too much? So we know 9's way too much, right? Okay, so give me a number that's less than 9. What about 5? Can we try 5?
Yeah.
Okay, let's try 5. See what happens. We know that that's 40, right?
Mm-hmm.
And that's 9. Oh, we're getting closer. That's 90.
Mm-hmm.
So let's
6.
try 6. Okay. What's 6 times 8?
6 times 8 is 48.
48. Carry the 4. That's 108.
8.
I'm going to go one more just to make sure.
7.
Okay, let's try 7. What is that?
7. Wait, no.
56?
Yeah.
Okay. And that's 126. Is that too much?
Yeah.
So we know it has to be 6?
6.
Okay, so put a 6 right there. And then we know that that's 108. So let's put our 108 here and subtract. Oh, 108. Is that a 0? There you go.
Oh, yeah.
So
So that'd be
is that 11 again?
yeah, and this would be 8, 1.
And what do we need to bring down again?
The 9.
Are
So
we,
we know
Yeah.
this is gonna be 6.
you got it.
And then
Are we repeating? Is this repeating, Hudson?
yes.
Okay, so if we're repeating, we know then the next number is going to be 6. Well, so is this going to be $1.66, or is that going to be $1.67?
$1.67. Wait,
A dollar
no.
what?
Wait, yeah, $1.70, right?
No, no,
No.
66
Wait, no.
or 67?
67.
Okay, write that over here for me.
Wait, yeah.
Okay, erase. Let's do the last one.
Now, after you erase, Hudson, I want you to think for a second. We're going to reason through this a little bit, okay? Once you had known that it was $1, right? You knew it was going to be $1 something, right? Because you started with the 1 point, okay? would that be a better deal or a worse deal? Would you rather pay $1.67 for every Post-it or only 83 cents?
83 cents.
Okay.
So you already know the middle one is already going to be out, right? And if you only had to find the best value, you could have just gone, all right, I got $1. I don't even need to do the rest of it, okay? So what I want you to do is I want you to think for a second. If we had a 12-pack and now we're going to a 24-pack, how many times does 12 go into 24?
2. Oh,
2 times, right?
2.
So I doubled the amount of Post-its. So how much did 12 Post-its cost altogether?
Together 99.
Right, it was $9.99 for 12 of them,
And,
right?
and if we round that to a whole number, $9.99 can round to how much money?
Or $10.
$10. Okay, so if I'm doubling the Post-its, and that's $10, then if I double $10, how much money does that make?
20.
20. But look
So
at the
we know that's
24.
going to be more, right?
37.
Is that more than $20?
Yeah.
So that's definitely not going to be a good deal, is
that's not going to be a
No.
good deal. So which is the best deal then?
B.
There you go.
Nicely done.
Good job, Hudson.
Good job right there. Hey, we do have phone tutors available until 5:30 this afternoon. But time now to see how math and science is applied other than inside the classroom.
Earth is constantly changing the way it looks, and there's more happening beneath our feet than you might expect. Can you tell the difference between these two mountains? The difference is earth-shattering.
The difference between a mountain and a volcano is that volcanoes are formed from lava, whereas mountains are not necessarily formed from lava. Volcanism changes and shapes our planet by giving us new land masses, such as Hawaii, such as Iceland. And it also builds these tall, mountain-like structures on the surface of our planet. And in many cases, it actually helps to make the ground more fertile for planting of different types of crops.
Volcanoes are places on the Earth or other planets where molten material from the inside comes up and flows out or explodes out onto the surface. Volcanoes will form anywhere that the material from the inside can make its way to the surface. Sometimes the material will just shove its way up and make its own pathway. Other times it'll follow a fracture or a crack through the rocks at the surface.
Faults are just cracks in Earth's crust that form the boundaries for Earth's tectonic plates.
One of the things you can actually tell right away from looking at a volcano is if you look at its slope. If you just look at the volcano as a whole, it's just the height divided by the width. A shallow sloped volcano was one that was formed by magma that had a low viscosity, that was runny. And a steep sloped volcano is one that was formed by a magma that was sticky. When magma moves around, it has to push the rocks around. And one way that we can measure that is through the breaking of the rocks using seismometers.
Volcanoes play a role in how Earth looks today. But did you know that volcanoes are on other worlds in our solar system? You didn't? Well, that's not your fault.
Mars has volcanoes. Actually, the largest volcano in our solar system, Olympus Mons, is on Mars. Venus has volcanoes. Jupiter's moon Io has lots and lots of volcanoes, and there are hundreds of volcanoes on Io's surface, and they erupt daily.
Not all planetary bodies are made of rocks, and in fact, in the outer solar system, the majority of the bodies out there have an icy surface. And so through heating and other mechanisms, you can melt ice just like you can melt rocks.
And so when we have volcanism on these moons, instead of taking the form of hot rock or lava that erupts onto the surface, we have slush that erupts onto the surface. What we call this cold volcanism or this icy volcanism is cryovolcanism. If you have a planet that has a very smooth surface, then you know that volcanoes or cryovolcanoes have been active. You know that there's been some fluid, whether that be lava or when you're talking about icy volcanism and icy lava or cryolava that's erupted onto the surface and it smoothed the surface out.
Cryovolcanoes? Cool. So there are different types of volcanoes, and they can be found all over our solar system. But how do we know this?
So the technology that's used to explore volcanoes that I use the most is basically data that comes back from robotic spacecraft. So NASA has sent spacecraft to many planets and moons. From these pictures, we're able to determine how tall these volcanoes are, how wide they are. These spacecraft also have instruments that tell us about the composition of those volcanoes. What we're able to do with that information is we're able to use then computer models and mathematical equations to try to figure out how these volcanoes formed, how runny the lava was that formed them.
Other ways that we can monitor volcanoes include paying attention to gases coming out of fractures around the volcanoes. A really big volcanic eruption can have global effects. Something big like Mount Pinatubo put so much ash into the air that it actually cooled the earth off for a little while.
It's important to study volcanoes because they teach us a lot about the interior properties of planets and moons. So if we see volcanoes on the surface of a planet or a moon, we know at one time or another that the interior was warm enough to sustain that type of activity. When we think of our own planet Earth, volcanism has been very important. We have this very nice atmosphere that, full of nitrogen and oxygen that we breathe here. Early Earth's atmosphere was actually formed from gases that erupted from volcanoes.
It's important to study volcanoes no matter where they are. And thanks to NASA, we know more about volcanoes on our planet and in our solar system. Talk about explosive science. For Real World, I'm Michelle.
All right, nice to have everybody back. We do have phone tutors available until 5:30 this afternoon. Hudson is in studio. Back to the board, young man. Put up that ever popular division symbol up there, where we're going to divide.
Wait, no.
There you go. What number would you like on the outside?
7.
7. You don't want to make it like 247, just 7? I'm only kidding. We'll leave it at 7. All right. Let's go 2. So go ahead and start writing these down. 2, 1, 7, 1, 4.
1 and 4.
There you go. All right, go to it, young man.
7 doesn't go to 2, so it goes into, but it doesn't go into 21 3 times. 3 times 7, 21. 21 minus 21 is 0. It's down to 7. 7 goes into 7 one time, and then 1 times 7, 7. That equals 0. Bring down the 1.
I'm going to move this down a little bit for you first, okay? So you have some more room. There you go.
Okay. 1, and then 1 goes into 7, or 7 goes into 1.
Ooh, does 7 go into 1?
No, 7 does not go into 1.
So what do we need to put? We still need to put something above that 1. What are we going to put? You're fine with that. That's perfect. But we need to put something first above the 1.
We put 0, right?
There you go, 0.
And you know what, Hudson? That is a common mistake a lot of students forget to do.
And then 7 goes into 14 twice. So, and 2 times 7 is 14.
So what is your final answer on this problem?
0.
What's our final answer, though? What's our final answer?
Is
up, look above.
Wait, no, 3,000. Wait, 3,160.
There you go.
Wait, no,
Whoop.
0.
There you go, 0. All right, that's the importance of making sure you write clearly so you don't get messed up on those numbers.
Yeah.
Nicely done. Well, you know what? We do have one more opportunity to go visit with Devin and the fine folks at Affinity Truck Center.
Hey, thanks a lot, Mike. We're back here at Affinity Truck Center, joined right now by David Gleim, Master Technician here at Affinity. David, thanks for joining us today.
Got it.
So, we're talking a little bit about transmissions, and the key part, the big role that a transmission play, I think when people hear about it is like a gear shift, but for some of our viewers, maybe middle schoolers or 4th graders and beyond, exactly what does a transmission do in a car, in an engine?
Well, transmission basically is the same thing as your gears on a bicycle. You have yourself as the engine, and then as you turn the front crank, you can change the gears in the back. You're doing the same thing back here, so you can change your speeds. For example, right now this is in gear, and then for so many rotations on the input is so many rotations on the output. And as you change those gears, you can change your speed, change your force, and also change your direction.
So the different sized gears interact with each other is going to allow for a different speed output here, which is going to allow, for example, the tires on the axles in the engine to go faster and rotate quicker to allow for more speed on the vehicle. So, tell us a little bit about kind of the role that ratios and rates play as far as the work that you do.
Well, in trucking itself, we're hauling heavy loads. So ideally, there's a fine line between having enough power and then having enough wheel speed where you're not bogging down. So when you can change your gears, you can take that 80,000 pounds and go 55 miles an hour down the road without having to be either one, bogged down, or working too hard and not going anywhere, is basically where it boils down to.
So why don't we talk a little bit about, from what we see on the camera, there's a whole other set of gears beneath there too,
right,
that you may not be able to see, but all of them work together. One thing that I think our viewers might notice, which I think is interesting as far as how they might think of gears, I think we generally think of gears as very kind of rigid and geometric, just like a square tooth and then an opening so that they fit in together. However, on a transmission like this, again, we're talking about something a lot bigger than you might see in your standard car engine, because this is meant for tractor trailers. But the gear teeth tend to be slanted over here. That's an interesting design that differentiates between what we generally see in a passenger vehicle.
That's right. Like on a bicycle gear, they're just they're straight cut gears. But if you can see real carefully, they're a beveled cut helix gear. And what this allows you to do is to transform power across the tooth gradually, so you're not putting the load on it directly, like a bike on the chain again.
And that matters too, because you're not going to get as much mileage out of a bicycle as you might get over a tractor trailer, which depending on the job you have, is going to be heading across the country multiple times a month or a year. So it puts a lot of wear and tear in. So how does some of the math that you work with factor in with the work that you do to keep these trucks on the road?
Well, there's a lot of factors in the design in these transmissions, and also too, the truck has the ability to sense the load of the truck going down the road and to select which gear is optimal for its performance and also for fuel economy. So in doing such, the whole package works together as one.
So there's a lot of different considerations as far as calculations you'd have to consider when it comes to the type of transmission you're working with and the repairs that would need to be done. We're talking about fuel economy based on the engine itself. We're also talking about the amount of force with the mass in the bed of the truck, but also if there's a steep incline or grade.
Right.
So that, talk about how that might factor into the gears in the transmission.
Well, that too, everybody knows if you're going down a hill and you don't have much braking force or anything, you're just going to keep going faster and faster. Well, in the transmission also, not only you have the gears to make you go forward optimally, but also you have the ability to select a gear to help slow you down going down a steep grade.
Well, David, thank you so much for bringing us in to take a look at the work that you do and the toys you get to play with every day. That'll do it here from Affinity Truck Center for the last time today. We'll find out where we go next time. Until then, back to the studio. Mike, take it away.
All right, thanks for that, Devin, and also thank you to everybody involved over at Affinity Truck Center. Certainly a pleasure working with those guys for the second year in a row. Hudson, a 5th grade student from Stockdale Elementary, did you learn anything today?
Math is hard.
Math is hard, isn't it, right? But with the proper help, you can learn some things, right?
Yeah.
More importantly, did you have fun today?
Yes.
That's what I wanted to hear. Hey, and until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Bakersfield West Rotary STROOPE Family Foundation, Panama-Buena Vista Union School District, Bakersfield City School District, KERN High School District, and AC Electric Company, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.